Welcome.
One hang on. It's like stuff. Okay. Yes.
Hello, welcome to the online version of the workshop. I'm going to explain today about makerspace, maker case, and the laser machines, laser technology in general, and how we work on those things and what we're making.
And I'm sharing also the screen now. Yeah.
Okay.
Thank you. Okay. Thanks.
So that's makerspace, maker case, and that's a laser machine. That's how most laser machines look like. It has three main components. The golden ones behind this is the laser tube. You have the head of the laser that runs on rails, and you have the bed that can go up and down. Now the head can go on an x-axis, and that entire thing can move on the y-axis. So basically, it can point everywhere on the bed. And how it actually works, the laser tube shoots a beam which hits a 45 degrees mirror over there. This is a static mirror. Then it hits the mirror on a rail, on the y-axis rail, and this can move anywhere in this direction. And this one is another 45 degrees that shoots in this mirror that is on the head that can move on the x-axis. And through a lens, it goes down and hits the things that you want to cut. Now, a laser, someone asked me yesterday about safety. So those machines usually have a system that if the door is open, it turns the laser off. It's an invisible laser. But even if you somehow manage to, you can hack those machines with magnets to keep them running even when the door is closed. You have to leave your finger quite a long time until it starts to make a hole. It's not that dangerous, especially not those very weak machines, but it's not recommended. So the bed is moving up and down because what happens is that the laser has to be as focused as possible to get the maximum amount of energy on the tiniest dot. So the laser goes through a lens, and then the lens has its own focal point. So if we use a thick material, the bed has to go a little bit down because we want always the focal point of the laser to hit the edge of the material. So if we use a thin material, the bed has to go a little bit up. And I'm going to show you later how you set the machine. This is quite easy. A laser also, there are two main parameters. There's the power and speed and time. And I can explain it a little bit like, so power, you can choose either use the maximum power of the laser or less, depends on the material. It's a little bit like a marker. So if you use a dark marker, it's a high power. If you use a light marker, it's like low power. And the speed and time, it's similar to what happens if you leave a marker on a paper for a long time, it attracts more and more and more ink. So even if it's a weak marker, a small marker, after a long time, it will make a big dot. So here, this is a laser machine, 30 watts. There are much bigger machines, 400, 500 watts. So potentially, this tiny laser machine can cut very thick materials if you let it run very, very, very slow. So when you have less power, you can still use thick materials, but you just have to run very slow, much slower than big machines, powerful machines. Another aspect of all laser cutters is they can work in two different modes, cutting / vector or engraving, which is raster. So this cutting, what happens if this is our shape on the DXF file, the laser, this is the laser line, it will just follow the shape and will cut it. or we'll also can mark. If we go faster and the laser doesn't go through all the material, it will make a mark. Sometimes we just want to make mark. Engraving, if this is our shape, it works a little bit like old CRT TV that basically was scanning. So what happens, the laser goes like this, back and forward. And where there is a line, it will turn on, and here it runs off, and on, off, on, off. And this allows you to make engravement. It potentially allows you to create 3D images. So if you actually take a photo, like a JPEG with gradients of gray, it will make a 3D object. This is also used mostly to make rubber stamps. What happens is that you reverse the image, and then you can create a rubber stamp with laser. So yeah, now I can show you everybody. This is the software itself, the website itself. I choose a simple box, for example. I go for millimeters, let's say 100, okay, whatever. I can choose if it's an outside or inside dimensions. I can choose the material. In our case, we have to go to custom because it's a 4 millimeters. And then we can choose whether it's open and closed. And we can choose what kind of fingers we want and how many. And then we just download the plans. This is the thing. We just can save it as, we'll save it as SVG. One moment, where was that? Download. Does it work today? Oh, it's just very slow. So this is our drawing. Okay. We have the object. I'm going to ungroup it. Better to set the lines to hairline, and then it's mathematical lines that have no real thickness. So we can see this is the right bottom. We can delete those things, or we just don't have to send them to the laser. And the nice thing is now you can also go and let's say you want to add the hole, or you actually can on the right side you can well, this one is not editable, but if you want to add text, you can later send this text as an engravement, so you can actually engrave on the box.
One question.
This
SVG files have problems with the measurement. Getting into the laser, and then maybe that has been 20 centimeters is now 12 centimeters or something. I think this SVG files have no or only counting pixels.
I don't know. I didn't really encounter, but you can also set as DXF. This website allows you to set the DXF as well.
DXF is working.
Yeah.
DXF has real masses, and with SVG I had problems.
I actually didn't really encounter such problems, but maybe it depends on versions or.
I read in Wikipedia, and they say SVG has no real masses, just this pixels, and then yeah, that's a problem for laser, I think. This problem several times.
I think there are more SVG formats, and you need to pick the right one to make Corel Draw or the software of the printer to read it as a measure.
There are different types of SVG.
Yeah, because so here I have millimeters,
Yeah.
and I managed to bring the millimeters then in Corel Draw, and Corel Draw then makes the exact measure in the laser. And so, but yeah, sometimes I see that there are is mismatched, so you need to check that the measure gets.
Yeah. So for Inkscape, there's also a plugin, so you can convert directly to the laser cutter. Yeah. But you have to fiddle around a bit. It's like most people I know, they're using SVG.
Yeah.
But of course, like you need to write conversion and try out a few times. And I guess that's what we do today. Yeah.
What is the best format for the file? SVG or
So
what is
of
the
course,
standard?
I don't can go into detail, but like what I know is like that vector graphic is always the best. You know, so vector SVGs, for example, vector. But like, what do you say best format? Is there any best format? I think different formats maybe. Yeah.
I like using DXF. Mostly I use DXF, but if I design something on Fusion, for example, I export it as DXF. But I also sometimes work with SVG. I save it and come here and open it with Inkscape. Or you can also open it directly from the laser software. It has its own special software. It works. If you just sometimes it happened to me, I needed to have a box. I was at home. I had to make some divisions for a case that I had. I just took the measurement. I came here. I opened the website on this computer here, where the laser machine is, and I created everything there. So I didn't come with other, but I also came with Inkscape here, both for the laser and they have also a cutter and vinyl cutter. And it always worked fine for me. I don't know. Never encountered such problems with SVG. But I guess it's also maybe depending on the versions. I know that they made some changes because this feature called hairline did not exist in previous versions of Inkscape. You always had you had to choose. I remember back in the day at FabLab Berlin, they also had a similar machine like here. And you had to select a point to make the thing work, like 0.37 something weird number, and only then the laser software can understand. If not, it doesn't work. But since they introduced the hairline feature, I think maybe this also solved it, because this is not a real line; it's a mathematical line.
It just depends on what the laser is doing. If the line is thick, the laser is going to engrave it.
So,
and then if the line is thin, then the laser is cutting it.
Yeah. So hairline is thin. It's like it has no thickness actually. It's a mathematical line. It's just a formula.
The laser is always cutting.
Yeah. But you can ask the laser to engrave it. I think it will just make it very, very thin.
Maybe.
Yeah, I once accidentally chose engrave, and I saw that it started to make this very, very thin line. It's almost like only one pass. But with the hairline, it always worked for me very well, and I never had problems.
The laser software I used before was red was for cutting and black was for engraving.
So with the software over here, you can choose any color that you want. It doesn't matter. It doesn't have to be red or black. And then the software sees all the colors in the file, and you can decide which one you want to do what. Because it's not just engraving and cutting. Maybe I want to, for example, this name that I made here, maybe I want to make it like that. I want to make it not as as an engraving, but I want to make it as a mark. So the laser is not, I want just to make a line. I don't want to cut the letters. I just want to make a mark. So in that case, I will ask the machine to move at 100%, no, sorry, like 50 speed. I think it's 50 millimeters per second, and power 20%. So you just make a black mark, and it's much faster than engraving. Engraving, the problem with it is very, very slow. There are special machines that use mirrors, and it's basically a tall machine, like the laser on the top, and you put the part down, and then it has a mirror that moves very, very fast, and then it can engrave this thing in 5 minutes, maybe even less. But those machines, the head actually have to work like this, and it takes a long time.
So that means it's not depend on the color of the line, but I need to figure out what is your machine doing to have a special effect. If I want to cut out the name right now,
Yeah.
I need to tell them.
If the line is thin and you say cutting, then it's cutting.
Yeah, but
if
that's
the line
an
is
extra
thick-
command for the SVG, or
Yes.
There is another step coming up now.
I will show you. It's basically, as I mentioned in the presentation, there are two factors in cutting laser: the power and the speed.
Yeah.
So, for example, if I want to cut 88 millimeters plexiglass, I can do it with this tiny machine here. You just have to go very, very, very slow, and 100% of the power.
so it depends also on the material.
This I will have to test. There are some presets on this software, but they're all not always correct, and also those materials are not consistent. Sometimes they could more condensed, sometimes less. So it's always better to make like a little cut on the corner to test to see if it goes all the way through. And if you want to mark, you go for a very, very low fast setting. So you give it a very high speed and very low power. So it will basically it's cutting. The machine doesn't care if the laser goes through the material or not. It just follows the curve. And with the amount of power that you set and the speed, and if the power is not enough, so to say, it will just make a mark. In that, if that is what you want.
So I set up the information for speed and power also in the SVG? Or
No, this
where-
is in the software. I will show you. It's quite easy.
Okay.
I usually use the settings. So
settings.
there are a lot of presets according to material, and those presets usually work. It's easier with plexiglass or MDF, which are artificial materials, so always the same. But since this is wood, it's not always the same. So what I recommend now is maybe we split into two groups, because the laser room is very, very small. And then how many people are we? We have 10 plates.
How many people are we? 1, 2, 3, 4,
I have extra plate.
10. Yeah,
Is it
10.
possible to
But
laser
10
cut
people.
something else if someone wants to click
Yes.
the thing? I have a nice box to build. If it's
Yeah.
Yeah, of course.
I mean,
How long does it take?
so
you will.
I mean, maybe if you can join, you just join one of the groups, and you will see how to do it, and then you can do it yourself. I will have to look at it because you're not allowed to use the machine without workshop before. But you will get it. It's quite easy. It's very easy to work.
Thank you.
But I think since I have 10 plates, everybody can make a box according to what they want, and they will just go through the process. And that's it. So I think we will go 5 people and 5 people, and 5 and 4, or 4.5 and 4.5, depends.
No problem. So how many of these do you have?
I have 10.
Yeah, let's give everyone one. Okay. Nice. So people can get a feel for the material.
Thanks. Yeah.
So what material you can use? You can. This is wood now.
This is wood. You can use any organic material, wood, MDF, plexiglass.
So MDF is this pressed kind of leftover wood or something,
Yeah,
right?
MDF is it's called chemical.
Yeah. Ah, nice. MDF.
You can. There are fabrics. You can, for example, I took some fabric. And I cut it and glue it on the glove, so when I make a turn on the bike, it's much more visible. So that's just fabric. Now with fabrics, what I found out that if it's a woven fabric, it's probably gonna fall apart if it's small parts, because weaving is not very strong. But if it's a knitted fabric, it's going to hold itself much better. What is important, not to use materials like ABS is not allowed, vinyl is not allowed, because those ABS.
Lego.
It's
Kind of plastic.
Plastic.
Yeah, because they emit toxic fumes. Now, plexiglass does not contain carbon. That's why it doesn't leave you a black mark when you cut, because when you cut wood, you can see it's always black on the sides because the carbon burns. There are plastics that you can cut which are not toxic, but they will leave you, might leave you a black mark, which is not very nice. There is I think on the wiki of the Exine, there's a list of materials, allowed materials, but you can just, many universities, they have a hackerspaces, they have on their websites list of allowed materials, or you can just go to any manufacturers like this one. I think it's Epilogue. There's Epilogue, Trotec, Universal Systems. There are many companies that make lasers, and all of them usually have on their website a list of materials which are allowed. Polypropylene is okay, but I think it might leave you a black mark because it has carbon inside, if I'm not wrong. I think here they ask not to use leather, real leather, because it's kind of stinky when you cut it. But technically it's okay because it's natural and it's not emitting any fumes.
What about Forex? What about Forex?
Forex is ABS, not allowed. Forex, you have to use a CNC machine. There's a CNC machine downstairs. You can cut it at a CNC machine.
How much did these cost?
This each 5 plates cost, I think it was 7 euros, 8 euros. Yeah, so we can start when we just go to the. If some people will join me and. Oops.
Yeah.
Because of loss. Yeah, but
Yeah, no.
and yeah.
breakfast.
Okay. Hey, let's to wake up. Let's make a big round of applause for Eitan for like So, who's the first group?
I want 30 seconds.
Volunteers? More volunteers? We need 2 more volunteers.
Yeah.
2 more volunteers. You guys relaxing? Yeah, I see a gentleman raises. Good. Let's go ahead. Okay, and 1 more person. Yes. Yeah, everyone can have their own. Yeah? I'd like you will introduce first and then like do more. Okay. Nathan, it's on.
I have a box. A modular box. Produce modular pieces.
Ja, sehr gut. Ja, mit den Materialien ist so, es ist ja so wie Feuer, ne? Und wenn du da so diese Plastik können die auch ein bisschen anbringen, auch wenn der Laser und die Schwierigkeit ist natürlich auch mit dem Holz zum Beispiel. Da muss man das Erfahrungswerte natürlich alles durchlesen. Aber wahrscheinlich ist es so, wenn man es mal ein paar Mal macht, dann weiß man schon, wie man es aufführt. Es ist nicht so wie Drucken oder nicht so wie Schneiden. Selbst beim Schneiden hast du ja, also wenn du jetzt sägst, so geht ja immer ein bisschen verloren. Das heißt, und hier ist es natürlich auch so.
Ja,
und die besseren sind auch lesen. Auch so Sachen, die ich denke, so als wenn du versuchst zusammenzuschicken. Ja, Boxen oder so, die du bauen kannst. Und bei kleinen Boxen, das funktioniert ist, dann bin ich das Gleiche. Und 10 Minuten später passt es nicht gut zusammen.
Yeah, that's the point
Nicht.
Draw. Also ich habe auch schon so ein 3D-Bild gebaut.
Genau.
Da habe ich den einen probiert, da sagen die 0,2 Millimeter. Das ist der Strahl an der dünnsten Stelle. Und ich habe da immer 1200 zugegeben. Jetzt sind die Boxen so, dass die
Genau.
dann kann man die einfach so drücken, fertig.
Ja, so ist es. Dann hast du auch schon ein bisschen. Ja, das ist schwierig zu sagen.
But maybe the website makes all of those things.
Und auch mit so einem Finger. Für mich
Ja.
Für mich sehen die Boxen am besten aus, wenn die Finger genauso dick sind. So breit sind die das.
Well, should be fine. That one.
Also das ist für mich so optisch halt schön.
Ja.
Ich habe jetzt leider nichts mitgebracht. Ich wusste nicht, dass es heute
Ja.
Boxen geht oder so.
Ja, aber du hattest ja gestern auch schon ein paar Sachen gezeigt.
Ja, die habe ich wieder dabei.
Ja. Das ist auch gut zu schneiden, ne? Das Material ist relativ billig.
Ja,
Und,
und
Ja,
man kann es auch recyclingmäßig machen. Man kann auch Standortwände nehmen.
ja. So alles mögliche, ja. Ja, hast du da schon einen Plan für zu Hause alle möglichen Sachen zu bauen, ja? Brauchst du einen Laser irgendwann, ja?
Na, ich gehe zu so einem ins Happy Lab. Das
Happy Lab.
ist relativ billig, aber das ist nicht
Ja.
so, das ist mehr wie
Ja.
so ein Copyshop oder so. Man kennt sich und man redet immer ein paar.
Du warst auch auf dem Happy Lab auch, ne?
Ja, ich war auch Mitglied da. Aber es war immer kompliziert, an den Lasercutter zu kommen.
Ja, weil er immer dran ist.
Ja, aber 2 Stunden, manchmal braucht man 4 oder 8 Stunden am Stück oder einfach zu prototypieren und dort dabei bleiben und dann ist es ein bisschen komplizierter.
Ja, ich brauche meistens 1 Stunde und wenn dann keiner nach mir kommt, dann mache ich weiter.
Jetzt habe ich Lasercutter gefunden bei der Uni und so. Ich kann so danach durch ein anderes Projekt, ich konnte Tourenlaser. Und das war leichter, weil es gab niemanden. Also keiner hatte Zugang und deswegen ist es immer frei. Okay.
Und ich habe nichts gemacht. Da hinten dann.
Ja, genau. Das ist ja, ich sag das. Hier. Skype hier mal, das ist das Beste. Wir wollen die und dann sieht man jetzt die Waren neu aufstellen. Hier, die Leipzig-Liga wird Lagerenergie und Geschwindigkeit. Das ist dagegen gestellt. Und dann geht es wieder zurück mit sehr hohen Wirkungsgrad. Generator umschalten und bremsen.
Die schieben sommerlich.
Genau, das ist die einzige Idee. Und vielleicht mal so ein paar Schnell-U-Bahnen hier in Berlin auch. Die dann hier ist so einen zentralen Platz auf Hermannplatz oder was weiß ich und dann bis Steglitz oder so durchfahren. Dann eben wirklich runter von der Geschwindigkeit und dann wieder hoch. Man stört dann die anderen nicht, die Installation nicht und dann geht es durch. Hohe Geschwindigkeit. Letzte 10 Stationen waren natürlich überall anhalten müssen.
Make a state, make a state.
Ja, man kann das ja zwischen jeweils immer wieder.
Das geht auch.
Man bräuchte ja nur ganz. Damit sie da nicht nur einen Monat das hinschiebt, dann
Wir haben ja natürlich auch, wenn man so schnell ist,
genau, das letzte Stück ist wahrscheinlich.
Ja, wenn er hier genug Strom hat. Okay.
Also hier bei dir rein ja dadurch, dass das niedriger ist. Das genauso hoch wäre. Ja, dann würde die Finalung.
Das ist sozusagen der Motor sozusagen.
Hast du das mal mit verschiedenen eine optimale
Ja, diese Rechnung, glaube ich, Kreis. Zur Rechnung.
Is there anybody watching?
Wie hast du das gemacht?
Ich bin seit Jahren an Laser und
Das ist schon ganz krass.
ich mache so Kindersachen damit. Genau.
Das ist auch
Wow. Das ist Simon, guck mal in deine Augen. Guck dich immer an, ne? Nein. Genau. Das kommt auch aus dem Laser. Das sind was für Kinder, die malen müssen. Oder wenn die älter sind, dann gibt es eben nur so ein Fett. Dann malen die ihre Figur da selber drauf.
Und dann ein Lasersystem.
Gut ist, das kriege ich schon fertig gelegt. Laser und so, dann das hier raus.
Wenn man hier malen sie das drauf und dann Lasers.
Nein,
Das geht nicht. Okay.
ich bin am Laser, mach das mal hier. Eine Serie. Entweder das hier oder das hier. Ja. Und dann gibt es einen Workshop. Da gibt es Farbe, dann gibt es Pinsel, dann gibt es Filzstifte. Und dann suchen die sich was aus und malen das und das nach Hause.
So wie Bücher.
Ich werde die Zähne schon mal weiß gemacht. Das sieht dann besser aus mit den weißen Zähnen.
Stimmt.
Also hier sind noch andere Zähne, junge Jahre anders. Ich habe dann so eine Auswahl. Ich wollte nur so ein paar Sachen mitnehmen. Alles fing an mit Luisa. Luisa war die erste.
Aber auch im Kind gemalt oder?
Ja. Und Luisa hat gelernt, ihre Augen zu bewegen.
Aber man muss jetzt schon mal programmieren können.
Zeichnungen, Vektorgrafik. Und dann ist Drucker. Also ich darf dann in dem Programm drucken und dann kommt da so ein großes Fenster auf. Schneller, wie viel Energie er verwenden soll. Das Papier ist, das so schneiden ist. Also hier ist alles schneiden. Jeder den Part hat. Da geht er eben hier lang und geht hier rum. Dann schaltet dann Laser aus und geht hier. Hier schaltet er aus, geht hier, macht also macht das relativ schnell. Und wenn der graviert, dann geht er eben so Zeile für Zeile rüber. Das weiß ich über 0,2 mm. Mit der 0,2 mm tiefer. Wow. Genau so ein Stück Holz. Vielleicht hat er noch eins übrig. Dann musst du im Wesentlichen wissen, welche Kiste und auf die Decke.
Maybe it's more actual something like very specific. It's like pictures. I'm just saying.
Wie schreibt das für die Website?
Je nach Situation ist es auch ein Stück. Also, jetzt hier kleiner, weil die ganzen die meisten haben noch richtig Spaß. I don't know. Guck mal, der Aktuelle macht das in den Folgen. Dann hast du das ganze 10 Tage.
so den Deckel den kriegt man auch easy, oder?
Es kommt immer darauf an, wie genau der also normalerweise ist es so, dass man das okay. Ja. Dein Holz da, zack, fertig. Ich bin zusammen. Hier hat es auch. Das ist das, was ich persönlich schön finde. Jetzt kriege ich nicht erledigt. Ja, du hast einfach den ja, ich bin manchmal
Das ist immer die erste Erfahrung. Was sehr interessiert. Ich habe hier gleich zwei Grüne. Nee, die grünen, was hier stehen.
Ja, praktisch. Wenn you sit at the front.
Yeah, I didn't know. Maybe I thought but now I
Yeah, I put it back there.
It looks what? Simple, but yeah. No, it's cool. You already did yours? Yeah. Yeah.
True.
we're going to type now something to change.
Yeah, that's what I said. I just did it perfectly. Like I did it perfectly, like it fits, but then I wanted to make it. Yeah. Like is it supposed to work? I thought that's the point of this form without glue. Like it's all.
He said that you can do it like this, that it sticks.
So now you know it's not true.
You would have to work more like
No, actually, well, you see, like there are no other spaces. Everything is perfect.
How did you manage to work that perfect?
No, I mean it's actually not that perfect. So everything sticks perfectly, but it still doesn't work, doesn't hold like the parts. Yeah, and I thought the point of this one.
Yeah, you can have some
Yeah.
glue and
Oh yeah, wait.
get a little bit weight on it. And
But I wanted to.
that's not hitting. Yeah. And you have two less fingers.
Less
More
fingers. More fingers.
Yeah. Mm.
At least I did it more
The
than.
material is not walking afraid. And to me, so it's perfect.
Yeah, because this thing is a bit. You're making your box.
No, I'm doing a very complicated design to laser cut. I always wanted to laser cut this, but it takes so much time to make it small. It has many tiny features.
Is it your first time cutting?
No, I'm experiencing it, let's say.
Okay, cool.
Also, er hatte gesagt, ich sollte Außerradius nehmen statt Innerradius. Bin aber dann auf Sidelinks gegangen, weil ich das die Nacht schon ausprobiert hatte, weil ich wollte die Seiten, dass sie möglichst quadratisch sind. Und da hat die Software meiner Ansicht nach einen Fehler dran, wenn du da Seitenlänge von in dem Fall glaube ich 8 cm hast, dann musste dann für den oben drauf noch zweimal die Dicke von dem Material drauf lackieren, damit es dann also 80 mal. Hier ist aber nicht ganz durch. Ne?
Das kann passieren.
Was machen wir da? Mit mehr Gewalt.
Das ist gleich ein Einbauer Cutter. So. Macht dann den Rest.
Aussprechen. Ja, ist noch ein bisschen.
Das machst du mit Cutter.
Das sieht man genau, halt mal die Hand so drüber. So schnell bin ich. Das ist ruhig. Ja.
Das ist wählt sich auch das Material, dann hat man nicht die gleiche.
Kann ja erst mal gucken.
Also du musst einfach gleich nicht aussprechen und dann raus. Wahrscheinlich geht es ja auch.
So,
Das
did,
ist ja.
did your thing work?
Nee, die Seiten sind ja alle gleich. Das ist.
Brauchst du dann Cutter? Oder wie ist das?
Ja, guck hier.
You also have this too much space. I mean, mine fits together, but it doesn't stay. And yours,
So.
so like mine.
Aber jetzt ist ja die Frage, du lädst die Datei hoch, ja? Du hast ein SVG.
Ja, genau.
Wo lädst du die?
And where is yours?
Dann geht in der und da gibt es ein Programm, das ist Forward. Das ist eine Base. Das ist wie ein Drucker gesehen. Weil da kann zeigen, also wir machen Vektorgramm,
When you use
da kann diese Bewegung machen.
Aber wenn ich dann jetzt so eine Standardbox hier haben möchte, das ist meine Bildfläche. Ich hätte das schon gerade noch mit da hingehen. Ich muss ja die Zeichnung erst ändern, wenn ich hier noch zusätzliche Löcher habe.
Ja, das mag dasselbe, aber du solltest sehen, dass du diese Datei herunterladen.
And that was single piece, yeah? Yes.
Ja.
Und nach dieser Datei kannst du dann gucken, was das
Then I think
Yeah.
all other people. Okay, I think it's the last person for doing it. Yeah, could do it without fingers.
I thought about putting together here downside, inside maybe a pattern.
Yolks and this.
What?
Yolks and this.
How do you spell
Eioxendez.
Du gibst ja danach einen Dateinamen.
Ja.
Da kann man es ja wieder runterladen, sozusagen danach. Oh, ja, tatsächlich. Aber wie man jetzt seine Dateien. Wie gut der USB-Stick.
Oh, this one works.
But you managed to make it. Yeah.
Yeah, one.
Does it make you depressed? Yeah, me too.
Ja, ich will auch ausgerichtet. Ja. Ja, dann richtig schön hinlegen.
This is the top one. Well, yeah. So right now I.
Oh, you have a
Yeah.
Fängt immer oben links an. Hier. So.
should have taken like
Hmm?
should have taken one like this.
Simple one. Oh, at least you have something sophisticated. And then, yeah, it closes. Right?
Yep. But the closing part is more built in.
Oh, actually, I think when you are holding it forward, so you can give it a start.
Und ich glaube, eine Spannung irgendwo halt selber.
It's actually, it looks like a temple if you remove just one of them. Like you remove palm. It would be like just one palm and another.
Jetzt ist der Meter. Lieber.
Ich nehme es an einer Seite an, genau. Das ist nicht das, was so lange brauchen geht. So ein schönes Objekt.
Und sieht zumindest aus. Habe ich das noch gesagt?
Das ist eine gute Idee.
If I wouldn't choose the most simplest one, I would think that I did it.
Oh, it's not.
Yeah, now I think it makes more sense here to start with like the most simple basic function, so that you understand the principle and exclude other
Da
criteria.
kann man dann islamische Geometrie.
Nein, mir das auf der Stelle nicht so machen. Damit das auf der Stelle
Genau, da habe ich das gemacht. Kennst du Venetal?
Willst du das aufschreiben?
Giri geschrieben. Ja. Giri mit D.
Where were you yesterday? I remember like yesterday, no one said that they are objective.
Nicht da. Der kann man immer noch wegnehmen.
Yeah, very well told. Wir haben 5 verschiedene Formen.
So now it works. Like a door.
Leute gesagt, dann gibt es noch ein anderes das hat Bowtie, geht dann der Winkel nach oben.
Genau, so eine Slingshot.
Wenn man dann auf
I don't know, someone said like press fingers.
Yes, I choose those fingers and I.
Does it work?
Yes.
und dann in einem bestimmten Winkel der die
And then
Linien zeigen.
Genau, ich hatte das auch mit Linien. Linien
this
Und
walls,
weil
yeah.
nicht jedes ganze die, wenn ich
And then
natürlich
can you
die
show me
gleichen
the
wenn ich einbaue, sind hier
And I'm so curious. So you're the one person that
mein
So
You need glue in there.
okay. So,
You just remove one and
Also dadurch sind die Linien, egal wie man das zusammenbaut, mal durchgehen. Das eigentliche Muster sind nicht
you need glue.
is it your first
sondern das eigentliche Muster sind dann die Linien, die man da
Grundpuzzle habe ich auch, wenn ich aber nicht viel weiter.
wenn du einen Mac hast.
The one that put keys in it has to be good.
Mm.
Und das ist die erste Verbreitung. Also, dann später habe ich mir die marokkanischen Kaffee Fällig. Und bei denen ist das Prinzip ein bisschen anders. Man arbeitet also nicht mit diesen gleichzeitigen Formen, sondern man arbeitet direkt mit den Formen, die hier dann durch die Linien praktisch ausgeschnitten werden. Und dadurch hat man aber dann Formen, die nicht mehr gleichzeitig sind. Das heißt, ich habe dann sozusagen eine ähnliche Version von meiner Geräte gemacht, der Laser heißt, wo ich dann aber erlaubt habe, dass die Seiten unterschiedlich lang sein dürfen, aber dann eben nicht mehr die Muster darauf, dann wieder Muster drauf. Die habe ich
I'm just thinking maybe I should make it small.
Wir haben das Ganze in 3D gemacht. Alle Seiten. Und platonische Körper, archimedische, Johnson.
Die Wörter hast du vorher schon angegeben, ja? Sonst wäre es nicht gleich gewesen. Du wolltest quadratisch haben.
Ich hoffe, dass ich quadratisch bin. Zu Hause muss ich immer auslassen. Sieht zumindest sehr quadratisch aus.
Also woher wusstest du denn die Größe, die du hier ausgewählt hast?
Ich habe, du hast 3 Möglichkeiten, diese Maßform einzugeben. Du kannst hier den Innenradius angeben. Ja. Du kannst den Außenradius angeben. Ja. Oder du kannst die Seitenlänge angeben. Der Haken war aber jetzt, dass ich an irgendeiner Stelle, weil ich das auch verrechnet habe mit der Seite, muss ich bei der Höhe die doppelte Seitenlänge, die doppelte Materialstärke.
Yeah, but like how,
weil er die Seitenlänge
strong is
hier
it?
verwenden kann.
You didn't print yours, yeah?
I mean, my workshop is starting now, basically.
Right now?
I think by schedule it would be now. I'm thinking more about that.
But I think you can start with maybe them, because they are the ones who are most into the technique and they would understand what you explain. Because for the newcomers, it's difficult to see. So the issues that you get far ahead in your path, because they are trying to learn to deal with the tools and they find everything online, and it's already a cube. It's already amazing. But then it's about putting it together with other applications, and then it's the matching what you're explaining. So I think you can work with the experts here. They would understand. Engineers. Yeah, more an issue. But yeah, it's for everybody also. It's good that everybody gets a
Yes, that's
an overview on the issue.
The main thing, yeah.
So, this is your box, yeah?
No, I'm doing something else. I'm trying to do. My box is a different one. I will print it separately. But it's something that I want to make and up here. I grow mushrooms and I want to grow mushrooms in such a way that it grows, changes color, and paints this shape in this.
You just have this frame with you.
Yeah, I bought it up. It's a standard frame.
Und dann kannst du
Ein
den
Frame.
Stick rein.
Also you want to put it
Yeah, I will put the
Und er hat
and the color what?
and the mushroom will grow and the color will come.
I remember you mentioned
Yeah, it's stability. The materials. And these here I want to study the aesthetics.
aesthetic.
Yeah, because it has some very particular aesthetic, haptic factory. So we need to study them separately, but then also in a different way. How it's seen, done for the students, and they don't have time to dive deeper. Make something that people say, oh, it's beautiful, because what they do is ugly. Because you're working with rotting things, and then you have the aesthetics of rotting things.
Yeah.
And then people associate that with the biogarbage, which is exactly what it is. What it is bringing here. Yeah, it's just a frame. It's actually
Does anyone still?
it's just a frame. Yeah, it's coming.
Nicht quadratisch.
No, maybe. No, maybe. Yeah, I thought that about the chair. The chair is really very cool, but it looks ugly, no?
Looks like it's coming from. Okay, you can be there.
Extra long this, again, extra lines. And then it's like just finish with the.
Du sagst, das Bild sagt mehr aus als genauso.
Achso, dann das ist jetzt noch keine
Ja. Die Breite der genau. Das ist sehr viel, ne? Du hast das Bild,
Also, ich habe eine Materialstärke von 4. Sie hatte gemeint, es wäre gut, wenn wir die Locken auf dann 4 haben, aber so Gutes machen. Sie hatte gemeint, wenn die zu klein sind, dann sind sie zerbrechlich. Deswegen habe ich dann hier 8 gemacht.
Also mindestens 8. Also ich habe es immer mit 4 gemacht. Ich habe es sogar so gemacht, dass es dass man nicht leben wird.
Ich habe aber nicht gesehen, wo man das einstellen
kann. Und dann notfalls legst du denn, wenn du was presst, wenn du das hier reinpresst, nach unten hin, dann so drauf. Dann, wo bestimmst du denn das, ob das genau passen wird? Nee, ich habe es wieder Hand gemacht. Ich habe so, wenn der Laser da hat 2 Millimeter Schnittdicke richtig eingestellt, das heißt, da muss ich 1200 eben nochmal dazugeben. Ich muss immer 1200 mehr in die Mitte gehen, in den Freiraum gehen. Das ist extra spannend.
Yes, that was the
Und
idea.
das ist einfach
Yeah. I mean, not communistic,
so
but
ein 3D-Puzzle. Wenn ich überall so die Wings darum machen muss,
friend who makes shirts,
da gucken die, welche Teile zusammenpassen. Du hast hier wirklich unterschiedliche Maße rein. So, das ist das Material, das ist dann hast du hier abgeschlossen.
42.
So, wir sind ja.
Did you make a plate?
No, I just gave her some. You could one should. I'm not very happy. Yeah,
Kommt auch daher,
I work from like this, And then of course,
Wenn das auch dann passen wird, dann geht's
so I wrote the story.
das ist
And I'm seeing the scene like this, and approaching, and then being looking at me. Everyone's just hammering. I take
You imagine this event.
Bei der Teamwelle und Teamwelle?
Du hast jetzt natürlich viel kleinere Zeitmenge. Guck mal, ob du da vielleicht größer werden. Es muss halt hinterher drauf passen. Die Datei sah vorher anders aus, da waren die beiden Fünfecke hier, das hätte nicht gepasst. Aber dann hat er uns diese Fünfecke da geschoben, das steht dran. Und dann hat hier tatsächlich zweimal gesagt,
Das macht so eine Maschine, ja, das schnell umschieben.
was ist das als SVG auch? Kannst du nochmal das Layout ändern, das ist nicht drauf. Ich habe nur hier.
And you are not starting now. Yeah?
No, I do it. Yeah, okay.
Das war ja hier
Es gibt so ein paar Leute, die machen was damit. Mit dem Rechner, der dann jeden hat, jetzt hat. So ein bisschen ähnlich.
how do you make the mushrooms not ugly? Not ugly and
Not ugly.
or aesthetically nice?
Yeah. Let's see.
Okay, you're not
That's an attempt. Yeah. Yeah.
but it doesn't smell or anything, right?
It smells also.
Ah,
That's also another issue. So I have to take the issues one by one. So it's not easy just to do it.
and what about? I mean, will all mushrooms start growing on it, like the bad mushrooms?
Mold.
Yeah, mold.
Yeah, that's also an issue. But when you dry it out, it's fine. It has to stay in a dry environment. Otherwise, it's circular. We have circular material, which means if you throw them into the something wet, but you can make sure they will biodegrade. They will show the circular side, and you don't want to see that while you're using it. So yeah, it's also extra on top. But I like this challenge, and it's why I studied, it's why I'm active. I work with artists, designers.
Dafür hast du halt sehr große Open Button.
Ja, ich meine, das geht nicht. Da muss man sich ein richtiges
Hier
Maß
kannst du
ausgeben.
hinterher die Texte abschreiben. Da die Teile ja nur verschiedene Farben sind, kannst du ja wieder
Ich brauche also auch nur die Löcher bei den N machen, ne? Ich muss noch alle jetzt definieren. Wenn ich jetzt hier Löcher drin habe.
alle definieren. Deswegen sind 8 Seiten schwieriger als 20. Du machst jetzt den Deckel noch an. Oder du gehst einfach davon aus, dass die Seitenteile sowieso alle gleich sein müssten. Dann machst du die Löcher in einen Seitenteil rein und kopierst das an. Ich weiß halt nicht, wie Die Problematik ist halt immer, das genau passend hier auf das Holz zu bringen. Das hat er anscheinend, oder vielleicht auch mit mal Glück, hat das super gepasst.
Also wenn du einen größeren Laser hast, dann brauchst du einfach ein größeres Stück und dann.
Der Laser ist ja größer. Ja mehr oder du musst dir dann, wenn das nicht passt, auf dem Ding hier vorne ist dann noch eindecken.
Also du machst die Dinge einzeln. Gerade wenn du so ein Stück hast, wenn du kleinere Stücke hast, dann hast du eben das hier einzeln und das hier einzeln. Guck dir mal, was du hast. Also die 4 Blöcke ist auch noch was rausholen. Da kannst du noch einen großen rausholen und dann nicht immer eben häufiger umlegen. Was ist das hier? Die Farbe? Die Farbe. Einzeln. So, ich kann ja jetzt erstmal. Okay. Dann ist es weg. So.
Aber es werden halt sehr kleine Kurven. Ungefähr halb so groß.
Geht dann ganz schnell runter. Warum? Wegen den Seiten. Ja, wenn du das nicht voll ausschöpfst, dann wird es kleiner und dann, weißt du, wenn du es in einer Dimension auf die Hälfte bringst, es sind 2 Dimensionen schon ein Viertel von der Fläche und vom Volumen her dann nur noch.
Das wird, wenn ich jetzt hier 10 eingebe.
Du kannst ja auch ruhig mal eine höhere
Das ist nicht verstanden, ne? So, jetzt will ich mir das angucken, ob das tatsächlich ein Stück dazu ist. Das ist egal, wie viel. Nee, da oben hat sich ja auch geändert. Ja? So. Ja, ich muss nur aufpassen, dass die Zähne hier Worte noch sind.
Das ist hier schmale Dinger, aber trotzdem.
Und ja, hier hätte ich kein Problem. Das war jetzt wegen dem hier. Guck mal, da hat er wieder was geändert. Also hier wollte ich 42 haben. Jetzt. Auf 110. Und jetzt ist so. Ja, aber jetzt hat sich das wieder geändert hier. Muss man ja mal wieder gucken.
Ich bin schon praktisch, dass du also
Das hier von Hand machen. So,
ich habe mich dann immer wieder dran verführt, beziehungsweise eine Weile. Wenn ich das regelmäßig habe, muss eben diese 1200 das Telefon setzen. Und dann erst beziehen Pläne da gleichmäßig symmetrisch aufziehen.
ja, das hat er halt gemacht. Aber ja, hier hätte das
ja, die beiden hätte ich dann zusammengezogen.
ja, aber das muss ja hier auf der anderen Seite.
Ja, das zieht das auch zusammen, aber auf der anderen Seite.
Da hätte man praktisch den hier hochziehen.
Genau.
Wahrscheinlich ordentlicher. Schmal.
Das ist eben eine rechte und eine linke Seite. Die Teile sind trotzdem noch gut. Jetzt gefällt es mir. Aber da habe ich eine Weile dran gesessen.
Ja, jetzt habe ich hier, guck mal, wenn ich den hier ändere, Okay.
Ja, hast du nicht so viel Reibung, die auf jeden Fall kriegen. Je mehr von noch hast, mehr Reibungswiderstand.
Das kann das passen.
Ja, aber vielleicht, wenn man das noch lackiert, hat man den schon.
Na, wenn dann will ich die Kiste zusammenkleben.
Ich meine, jetzt vorher alles zwischen.
Ja, ist der Lack alles undefiniert.
Und dann den Lack mit Klebstoff.
Lackdicke. Ja, solange das flüssig ist, dann so ein Klebstoff. Ich würde erst zusammenkleben und dann passen. Oder nur die Oberfläche, weil dann man mit der Dunkel macht auch was.
Der packt mit Design. Steht kaum über.
Nee, da nicht, Alter, genau.
Da, ja.
Okay. Mario, in fact, actually, do want the pictures.
Trotzdem vorsichtig, dass man da nicht zu viel ablässt. Aber dann ist das Design
Scheint halt auch. Von Weitem sieht man ja sowieso nicht. Beim Fünfeck, beim ganzen Dreieck,
oder wenn das so kommt, wie er das so beim Zehneck macht.
da wird es doch einfach.
Ja, eigentlich so rechter Winkel passt. Und wenn die ganz gerade ineinander geht, wird das gehen. Das wäre sozusagen eine Verlängerung.
Am schlimmsten.
Das kann gut sein.
Ja, ich habe auch gesehen. Maximale Überstand. Beim Endlicheck ist das nicht.
Ja,
Und, ja, wenn du die Dinger die Seitenteile nebeneinander legst.
beim Zweiecken
Du kannst natürlich keinen Deckel drauf.
So actually in 15 minutes on foot. 15 minutes.
Ja, wenige. Aber es ist der Großgruppe.
Ja, eine viereckige Box. Ja. Jetzt kann ich das hier runter machen. Das ist das schon vom
Soll ich in anfangen?
Das hier ist jetzt ein, was du hast eine Grundfläche.
So, dein Workshop.
Von der Grundfläche gehst du einfach hoch. Nimmst du nicht Quadrate an den Seiten.
Ja, ich würde sagen, weil wir
So, so I switch on the sound again. I was muted before. So, yeah. So, okay. Ja, das macht nichts. So, genau. Also das ist hier Hands-on Workshop. Leute sind im Bild. So, schön, dass ihr da seid. Like, it's nice that you're still here. I hope you enjoyed the hands-on workshop here of Eitan for the laser cutting. And yeah, we just took a photo here. A big round of applause was there, and yeah, people are really excited. And some people made a very difficult project, and they're still working on it. Advanced, so we had all kinds of levels, and it's really nice to see how things are working out. So this was hands-on hardware in the wider idea of what is hardware, anything that you can touch, that you can make open. So we use the Inkscape, we use some web technology to do this. And yeah, it's good how you can see everything coming together in the open source sense and open source idea. And the next topic we'll have relates directly to this, which is open hardware making. And also, how can you document open hardware? Because people say it's open hardware, there's a few licenses, okay, that's good, but how can you actually replicate this hardware? How can you use this hardware? How can you repair it? What are the licenses that guarantees this? So this is the topic that we have in the workshop now here, and I'm very happy to have
standards.
Yeah, standards is related. A lot of topics. I won't be able to go to all the topics because that's what we will do in the workshop. And I have Robin here and Tim who will talk with us about it. And it's a bit of also discussion and some exchanges in a small group, but we have others following us online, and we hope this inspires you guys. And I will hand over to both of you to just do this. I don't know how much you guys online can.
I can give a little introduction, but I think main thing is really on site here. So.
But it's on site. But you get an impression. This is an important topic. Do you want to? Yes, you can stand here, or I can move around. But if you're here, it's all good. Yeah.
Okay. I will put the link to the project in the chat.
So. Oh yeah, that's a good idea.
Cool. Yeah, nice, perfect.
Yeah. So the workshop will also start with an example. We just picked one that's an open source insulin pump, which is from the technology perspective really simple. So we're going to look at the documentation we found on it. Right? It's not our project. We just picked one open source project. At least it's apparently open source. We're gonna go through. We run all the automated software that Robin developed to auto check basically all the documentation, and gonna see how it looks in the end. And from there, I think we can learn. And also, we're gonna do a little round of how documentation problems happened in the past. So yeah, I guess that's what we start with. So we're gonna share the links, and then yeah, hopefully we have some fun as well.
Thank you. So now I am on the project.
Robin.
Yeah, small interruption. Yeah, we're gonna look at this project and see how much it really is open source and what we think we improved, and maybe also see what you think and what do you think about our way of evaluating the project. I don't know how.
Have we a way to interact with people, or is that?
People sometimes put some comments, but I think it's mainly we on site. We just sharing this that we work on this topic.
There are so many people now. I think it's best that we focus on site, and then
we focus on site. We had the introduction.
If somebody can look at the questions and then drop them in when they appear, that's fine. But right now, I mean, the mic can stay on. That's fine, but no camera.
So thanks for you guys. Please join us next time here on site. Thanks for watching, and definitely we will share more more things. So, okay.
Do we have a way to share the screen? No.
No, the sun is waiting.
Yeah, if you share there, we can see it.
Where's the screen?
So,
Yeah.
Lindsay, can you
Yeah.
press
Yeah.
Achso, HDMI?
this one? And
Yeah.
when you press for the screen to go down into worse one. This one.
On the wall?
So there's another one down here.
Ah. Das war ein Timing, hä?
Keine Ahnung.
Yeah. Hey, be careful, just too much, just too much. Or just like move it to the front.
In den Einstellungen von Windows, aber das hat alles im Bildschirm.
Okay, perfect. Thank you. Thank you.
Ja, habe ich schon probiert, aber nicht. Ich glaube auch natürlich für das Spezialdings.
Wie hält denn sonst ein Bildschirm?
Das mache ich gerade nicht.
Also, ja, wie ein externen Monitor oder so?
Da kannst du ja reinschieben.
Das ist ja crazy. Ja, dann.
Das macht
So,
keinen Sinn.
habt ihr die Slides, vielleicht gibt es zwischendurch auch eine Website, die wir zeigen wollen, oder so, zum Beispiel auf Open Source Ecology. Das wäre gut. Aber ist es an?
Wir können anderes tun.
Ist es an? Kannst du mal anmachen?
Nee, kann ich
Bildschirm.
sehen.
Der hat was sein Speziallinux, hat wieder irgendwelche
Ach, du hast das
Restriktionen.
gebaut?
Und es gibt eine Website, aber die ist nur.
Dann macht es nichts. Wir haben dich ja, du kannst was erzählen und dann
Ja.
die Webseite online posten.
Wir
Ja, also
können-
legt einfach los.
Kann anderen, ja. Ich gebe noch einen anderen Link schnell rein.
Teil vor allem mal die Links im Chat, weil die kann
Ja.
Mario ja aufrufen und an den Bildschirm schmeißen.
Ja, habe ich ja gesagt.
Wenn man die selber nicht ankonstruiert,
Das wäre das Wichtige.
leichter einzuziehen.
Okay, Mario?
Was?
Kannst du Sachen an den Bildschirm schmeißen?
Nee.
Auch nicht. Kann jemand? Can somebody put links to the display, basically?
What do you want to put? Maybe I can
The
try.
links in the chat, basically.
I have
Als Basis eines dann rum ist und dann wieder Schicht machen und dann von einer Seite so Geschichte offen und das normale. Das heißt, manchmal sieht es so aus, als hätte es diese kleinen genau, nicht der einzige.
Muss ich zu Hause.
Ja, Ticket hier.
We could do a video conference and I do screen sharing.
Sind die Beamer so?
So maybe we just do like you said, Robin, to share a video or something.
Yeah.
Yeah, that would be easier.
You turn on the beamer.
Why don't you keep it plugged in and see? Like we can already start with it. Oh.
So I show you the result of this tool that we have for one of our sample projects. I don't know, can you read something? No? Okay.
Wait, let's turn on the beamer, please.
No, let's start. Let's not wait for technology.
Yeah, but we don't see.
We can talk about it.
If you put the link on the group chat, you can see from your phone.
Okay.
Yeah.
Yeah.
Oh, where is the chat? Telegram group.
Telegram.
You can add me.
Yeah.
Yeah. So I can see it here. So basically, yes, I can see the report. I want to know how do you apply the report on that repository. So there is the sample. Basically, there is a sample hardware project that you put the link here.
Yes.
And then you write a tool in order to check the documentation of this project. Is that correct?
Yes.
Yes. So and then how do you check it?
With this tool, but you see in the report all the things it checks. It says what it checks.
Yeah.
It uses it has some code and it uses a lot of external tools also. The sample project, it is a small, simple project, and we already optimized it. So most checks just say okay. But if we look at this sample project now, the one we posted, it has a lot of warnings. But this report is not online because we don't have access to the project. So I would have to show. So yeah, obviously all these checks are automatic checks, which can check some things, but a lot of things cannot be checked automatically, like how well is it written, is it really understandable, are all the things there you need to actually build the thing. These things, for this we have another process. Cool. Thank you. Yeah, so this is something that you see the small images there with the percentages. These are batches you can put in the README of your project. And if you put it there, then each time it's all CI based. So whenever you make a commit to your repository, so you change something in your hardware, the report gets generated again and these things change. So if you put it once into your README, it will always be the actual, the most recent value. And yeah, well, as just said, we also have a manual process. Thing where humans actually look at the project and evaluate it. And the idea is to also generate a machine readable report from that, which then will be used by this, if it exists, will be used by this tool and included in the report, in the final report.
Yes. So I just want to show again here, so the people, here this is the link he shared on the Telegram group. This is an example of one open source hardware project that called open source the insulin pump. And then you see here, this is the repository. And then there is a tool that Robin wrote, and then the tool will generate this report. Yeah. So basically, this is.
Yeah, maybe you can scroll down a bit. Yeah, so this is the main report. So you see the checks it runs.
Okay.
There's also a more elaborate description of each check, but it's not included here.
What is VCS?
VCS is a version control system. So, for example, Git.
Okay. Yeah. No generated.
Yeah. I mean.
And OKH?
OKH is another standard we're working on. I mean, we developed with a lot of other organizations. It means open know-how, and it's basically just a general set of metadata about hardware projects. So this makes the project indexable, searchable, comparable to other projects. It also includes, for example, one property that's called CPC patent. I mean, it basically it uses the classification that patent offices use. So if you develop your hardware, you can check, or you can look for which category your project would fall into if you would ask for a patent. Then you put it into your metadata, and the idea is that this, at some point, or maybe even now, makes it easily findable by people working in a patent office. So if someone if you make open source hardware and it has some specific technology, and then someone later on wants to patent the same technology, then the people in the patent office would already find your project. And if they find your project doing the same thing and it's open source, then the other person cannot patent it. So that would be optimal for you to never get into problems, legal problems with someone.
Okay. So what next?
But I have a question about this. So I was checking about the standard of the European Union for open science and things, and GitHub is not still listed on something that is acknowledged in the court. So because the main question is what is possible to bring to court a source that you already published that kind of invention and on that date. And because of the date issue, there were platforms that were green light and platforms that were red light, because you could change the date of issue of your post. And so therefore, is GitHub a reliable platform for this? Because I know that the only thing that I saw was Zenodo.
I've heard of it. I mean, Git alone is not, like you say, exactly like you say, because you can change the date. But what you can do is you can reference a Git commits checksum, the SHA, this long number letters thing, for example, in a Bitcoin transaction or any cryptocurrency thing. And if you do that, then it would become, it would work.
So, okay, you need to link it to something else.
Yes.
Okay, so the crypto, also the crypto is acknowledged. Nice.
I mean, I don't know if that's basically, technically speaking, that it's valid. I don't know if they already officially acknowledge that, but they would have to. If not, then there would have to be a court case, and that they would come to the conclusion, and they would have to come to the conclusion that yes, because that's something you cannot manipulate. Yeah. I mean, I didn't have time to do that yet, but that's something. There should be an easy way for people to do that, to not, if you do your project, you don't have to learn how to use the crypto to link your, Obviously, they should be easy, and we should provide that, but we don't have that. Yeah, and the same report, if we generate it for the sample project, it is much longer, and it's much more. It has a lot of red things, and not so much green things. Yeah, I wanted to.
So are you gonna demo?
Yes.
Is there a way to share?
I'm trying to get there.
Also, in the meantime, it would be interesting to know what challenges you had in documentation or what experience actually. I mean, which one of you already have tried at least documenting an open source project, hardware or software?
Yes, so the challenge
Okay, you're the only one?
Just close source.
Closed source, okay. But in general, it would be possible to open it if you have the structure right. It's also a good thing in general. The only stuff missing then is to have an open source license and have it publicly available, I guess. But the structure in itself is hopeful, I guess, for all kinds of documentation, by the way. Ari, I know you have been working on open source documentation at least. So.
Yeah, so we have we did quite a lot of documentation on our project. So basically for this, I'm curious, like what structure do you have on hardware? Because for, let's say, open source software, there are a lot of like sample out there where they, like in the README, what kind of documentation should go inside, how to, at first, I think that to begin with something, how can you run it locally? This is the first step, like how you can run something locally, and then all the requisition, what needs you need to install first. But the first thing is always like what to run and then they have sample how to install, what kind of feature uses, this kind of thing, and then at the end also. But I know that there are sample already out there for open source project. So what is the main difference between document hardware and software?
Yeah, hardware is much more complex because.
Do you have a sample structure that you could share?
We have a sample structure, directory structure. It's also checked in the checks.
This one here.
And I will. Oh, wait, I found you. I'm sending you. I sent you a private message, I think.
Okay.
To share the screen. Hopefully.
That works.
I am already sharing the screen in theory. Yeah, okay. Yeah. Cool.
If you press F11, I think then it's full screen.
Okay. And how do I make it bigger?
Control plus.
No,
Could you send me the link, please?
No, I can't send the link. It's not online.
Oh, no clean cat files. Interesting.
Yeah. So. Yeah, to see there are files of the 3D models, but they are only generated files. They're not the source files. So,
which one did you look through? The GitHub?
Yes.
Because I found FreeCAD files, so it might be due to the file structure.
I mean, this one doesn't say that there are not FreeCAD files. It just says that there are some that are not.
Okay.
Not source files.
Okay.
Which
in the case of STEP is still helpful.
Yeah, but it should not, because it's a generated file.
Interesting.
Yeah, here you see there are FreeCAD files.
Yeah.
Yeah, that seems to contain. Seems to be fine with electronic files or PCBs and so on. What is this? So this is. Yeah, whether it follows our directory standard, and of course it doesn't, because not many people know it. But yeah, it's basically not so interesting. Here, what is the, it has no license file, so that's obviously very bad.
Yeah, I actually filed an issue for that because they're mentioning the license on their website and some other in some other areas, but not as a license file in the repository. So the license is open source. It's Creative Commons license by share alike. But yeah, it's hard to detect. I even had to look around to find it. So I think it would be a simple step for them to improve the documentation, just adding the license file.
And maybe at this point, you also told me before that this project was most likely or from some research academic thing.
Yeah, they actually, I mean, maybe to tell a bit the backstory, it's just an example project. You could pick any project out there that tells they're all an open source project and evaluate it. That's mainly the one advantage of having such tools, right? So you don't have to manually go through and find the mistakes or the problems that you might run into while you're trying to replicate the project or trying to adapt it to your context. So you can actually identify the issues you might have. So in this case, it's an insulin pump, which is in itself a very easy project, but it could potentially help a lot of people in the world, right? Because it's simply built out of 3D parts and simple, easy to assemble electronics, and it's running on open source software, which is there for ages now. It's already better than the commercial software you can get for the normal insulin pumps. So it has a high potential. And I think these researchers, they also discovered that. And they did this first iteration, which is on GitHub. Then they did a second iteration, which then didn't use FreeCAD anymore. They did use SolidWorks, I think. And on SolidWorks, they used they used just a second version, but it's not on Git anymore. So you cannot really identify the Git history. But they published a paper about it. So, and in the paper, they really describe in detail the findings and the possibilities, and they still tell it's an open source project. So yeah, it's really a high potential project, but I think when the researchers are basically done with their paper, the project dies. So that's usually what we see with open source projects that are run through a research facility by a funded project, right? So you have basically this first iteration, and then the question is what happens after, because it can still help a lot of people. And of course, these projects have, there are multiple of these projects, not just one, it's just one example. And I think this might be one of the angles where these tools could make sense to identify the high potential projects, also in terms of how good is the documentation from the start, and then continue there, right? Because we with open source ecology, for example, could take part of such projects.
So let's go back to the question that you mentioned earlier. So how do we know what kind of documentation for project, right? So and there was a question. So what is the standard structure? So for us here, it's more important for us to know how a hardware project document, because for us, maybe we're not going to go and check, okay, what project is good. We have to think, but what is, can you give us a sample standard how documentation hardware should look like?
Yeah, here is the directory standard we made. It's just an example. Okay, bigger. Control possible. So yeah, just basically look at the first column here.
So you mean that a good project should have all these things listed there?
It doesn't have to have all of these. It depends. For example, there is parts for electronics, and if your project has no electronics, obviously you don't need that. Also, we'll go through some of them. So we have the license file, which probably all of you know from software already, and we have the licenses folder, which is from a reuse project. Maybe you know it. It's from the Free Software Foundation. It's a standard for more like documenting the licenses your project uses in a much more detailed way. Like each file can have a different license and different licenser, and it generates reports in a machine readable way and for humans also. So we prefer this one, and then it's probably going to come more and more in the future, but so far not many people. Then the README file, which just gives general information about the project. Yeah. OKH file, which I already explained, the metadata about open source hardware projects. And so, for example, if this one exists, then it can be sure, like a software can be sure that it's a hardware project. So we recommend to have something like this. Similar with the BOM file, which means bill of materials, which is just a list of the things you have to buy to create a hardware project. That's very common, not just in open source hardware, in all hardware production things, to have such a file. Yeah. This is also a problem because there's only one standard for how to structure such a file, which is a paywall. So we would need an open standard for that one. These, I'm not going to go into these. Okay, let's just go to the, yeah, here we define risk for resources, basically images and diagrams, photos of your project. Then source, where we have many different things, which be animations, calculations, simulations of your project, electronics files, firmware, mechanical files, so 3D constructions, software, and tests. Then we have generated files, which we put in one folder, because that means it can either not be in your repository at all, or it could be made as a submodule, which allows, basically that makes your whole project much smaller, and that makes it easier for people with less resources, or be it storage space or internet capacity, to still use it. Because the generated files are big, and if they change all the time, it would blow up your repository. There are technical ways so that it has a lot of benefits. And here maybe the most interesting folder is the documentation folder, where you have different documentations for assembly. That's assembly basically means you already have all the parts like here, and you just sorry, you just put them together. I don't know. I don't have the assembly instructions though. Okay. Then history, that's just next. That's not so important. But another interesting one is manufacturing instructions, which is different from assembly in that you don't yet have these things. You first have to manufacture them. So you'll have to laser print them, for example, and this would explain how to laser print them. While after that, you could use the assembly instructions to put it together. These are these words, nominations, are standard in the industry. Then user manual for how to use a thing, recycling manual if that's possible, workshop documentation. So that's one idea, and we did this structure because there was almost nothing out there, but we would want more feedback on it. We have some projects using it already, but it's probably like 7, 8 projects only so far.
The standard is also very recent, right? If you think about it, I think the version that's really usable, a year old.
Yeah,
Another year.
not much more.
Yeah.
And the good, I mean, why we want such a standard at all is that if you use that, then you can automatically generate more metadata from that, because you know the files that are in this folder are these kind of files. So you know, for example, that the user instruction is there, so you could have a check for that, and you could generate metadata about that in the metadata file, and vice versa. You could generate one from the other, and if both exist, you can check one against the other. So yeah, it helps in improving the quality, and the quality. I mean, all this automatic stuff and very standardized stuff helps a lot in. It's basically all about efficiency, so that if you have a lot of standardized projects that are using a lot of metadata fields and are like where the data is also checked for validity and so on, they become comparable. And that means that if you're looking for something and there are thousands of projects out there, it's much, much easier to find what you want. That's one thing that we always say. The counterexample is 3D printers, especially if we think in the beginning of 3D printers, that some people made kits, then lots of people bought them, they built them, and basically it doesn't work because this part is always wiggling and this one gets too hot and so on. So you have to figure things out, check online if someone do your own thing. And thousands or 10,000 of people did all of that in parallel, which is of course very inefficient. And that's what we want to change with such things. Yeah. Okay, let's go back to the checks maybe. Yeah.
Can you run the command like tool on the terminal so we can see how you run it? Like
this tool that generates that, yeah.
Yeah, because in order to generate this, what you see here, you need to run the tool.
Yes.
Can you run the tool?
Do you have another project example?
Let's try this one.
Yeah.
Let's try this one because now he only showed the file.
I mean, I run it on the terminal, but most people would use that in their CI, which is much easier. And I have, yeah. So in the README of the tool itself, here you have example projects, and you see for each example project there are 3 links. One is just the project's link, then the generated report, which is, for example, this one. And the third one is the CI script, which is all you need to copy to your repository to generate this.
Okay.
So basically, you only need to copy this into this file into your project, and then you get this.
Oh, and then it is a separate YAML file. It's not. We don't need to add any line into our CI file. This is a separate file, just to put on the repository.
Yes. I'll open it again. So this is directly in the root of the repository. This one is the file name. Yeah, you only need this. It's the same for all projects. You don't need to adjust it for your project.
Okay, so if you put it there, and then how it's run, how to generate the result.
And then you just make a commit to your project, and then for each commit, it gets generated the report.
And where the report will go to?
The report will go. You see it depends. If you have it on GitLab, for example, this is the URL. This is I mean, you can compare. Yeah, so if this is the repository, then the report will go here.
Like it's GitLab pages, basically.
Yeah.
You know GitLab pages?
I know GitLab pages, but the thing is, So you need to know, so people put it in their repository,
Yes.
and then where do they go to get this report? So,
Mm.
so this is
Should also be
this is a
documented,
workshop,
yes.
right? So you need to show people, you
Yeah.
show people how to document their project,
Yeah.
but the thing is to follow what you are doing. You
Mm.
also need to document so others can follow.
Yes, that's true. Should be.
I mean, we're still in the piloting phase, so I think it's also, if you look at the design of the result page, for him, it's not a problem as a programmer. He likes, like, he can see everything he needs. But for me, it's horrible, right? I can like, wow, that's only text-based, and I would like to have a nice interface where it looks shiny.
I don't think
So it's not necessarily for everyone the same what they need.
No,
But
no.
right now, we really need people rather want to test that in order to know, like, it's not yet in any way where we would say that's the, I mean, it's the only standard right now. So there's no other one that's trying to achieve the same.
So I think we
But
are talking about
definitely
two
to-
different things. So the thing is, the reported visual, I don't think there's any problem. So it doesn't
Yeah.
need to be beautiful. We are talking about
okay.
now how to use the tool. Before you join,
Yeah,
we
yeah.
were talking about how to use his tool. So
Yeah.
for a person who now looking at the tool, and I'm just talking about how people can use his tool. So we're not talking about how beautiful the report is or anything.
No, that was just an example
Yeah.
that there are
So
things
we're
to
talking
do.
about
Maybe
how to
this?
use the tool. Yes. Yeah.
Yeah.
Mhm.
Integrate. Okay, that's the question. I didn't even get your point then.
Yeah.
Okay, so
Okay, that's good. Thank you. Yeah, what else?
quick question, Robin. The projects that you have been working with, right? Were they following also instructions, or did they basically get them from you? Not to apply.
There was.
Or did you have a coworker? and
There
then-
were some that followed the instructions, yeah.
Okay.
But I mean, I think it was mostly like Peter and Jason.
Okay, yeah. I mean, it's very IT-like still, right? So I think for some engineers, it might be hard to follow in order to know. I mean, the advantages are clear. And in the end, if you have a list like that, it's much easier to follow certain checklists in order to improve the documentation. But to really understand the structure and how to implement it, it's sometimes it's harder if you're not from a code base, right? You're not really a software developer. Because in software development, it's already there, right? There are lots of standards, there are lots of ways to follow. Hardware.
So this, if you use this this metadata file that I said is OKH, then we already have like 35,000 hardware projects that provide this metadata. It's not that all of them provided as metadata file, but so for some it's just the platforms they're hosted on, they're provided for each project. So in the end, we have 35,000 projects. And what you can then do with it is like collect all this data and put it in a kind of database and then browse it. So you see that so far still basic metadata mostly, but it's already, I mean, you can understand that if there would be more data there, like what categorization it is it a chair, is it made of only recyclable materials, and so on and so forth. This would be could be very meaningful, and again, efficient. The idea is always to be efficient, because we believe that for open source hardware to be really like the thing like software already is, open source software, to win over proprietary projects, it has to be more efficient. And it definitely has the potential for that, because they're like, if all people that theoretically want to work with machines use them, improve them, design them, make them, could efficiently work together, they will be more efficient than basically any other any company could be. Yeah, we are trying to get there slowly. Yeah. Yeah, we have lots of small checks here. We check that all the documentation files, which are in general markdown files, do not contain global links to local files. That means that if one link in the documentation, if one file links to another file, it should not be using a URL, but it should be using a path, like a relative path, which means that documentation will work offline. Also, it means that if you click on the link in the documentation you're editing offline, you will get to the same file. I mean, you're documenting not to some file of maybe an older version, and then you're confused. So yeah.
Question. So the file, the CI YAML script, is it only on GitLab or?
No, there is a GitHub and the GitLab example.
Okay, so just, okay.
That's the first one is the GitLab one, I think. Yeah, so GitLab and GitHub.
Okay.
Of course, it can be done for others also. It's as you see, it's very simple. It's basically just using a Docker image and then using the standard run of the Docker image.
Yeah.
With, so it can be easily integrated into if you use GT or whatever.
Yeah.
Here. Yeah, that's not important. This. Yeah, so this checks for this, as I said, this reuse licensing information from the Free Software Foundation, which if you cover that, it's really very clear which license you're using for each file in a machine readable way. And yeah, it's good for efficiency again in the long-term projects. And yeah, these things are good. What else we have? Oh yeah, you see some more statistics.
Actually, very good work. I thought that, yeah, so thank you for doing this. I think that if open hardware project, it's easy for them. If they run an open hardware project, right, they can just run it. Okay. And you are currently maintained it. Is there more thing need to be added, or is already worked out?
More could be added, and I want to add more. I'm always happy for ideas for new tests. One thing that I'm currently working on right now, should be finished the end of the month, is that we will generate open batches, which basically just images that contain metadata. So the ones we saw in the beginning. Oh yeah, here we also see these are all the small tools that you use internally and the versions of them, which is interesting mostly for me. Or this one is what I was looking for. No. Okay, we have here. So this is just an image, but in the end of the month, this stuff is finished. This could also contain, I mean, will not be run by the standard tool, but you can encode basically whatever metadata you want. You can encode. Could be like all just this compliance thing, and could be So open batches is a standard that also all these like MIT online courses use. If you do a course and then you get an image that says you finished this course, and it is signed by MIT, so you can prove to an employer, for example.
You need to give the same thing.
No.
Yeah, that you finish the course and then with this and this grading. Yeah, and what I already said, that we would like to include the manual and the human labor evaluation of projects. But yeah, any ideas are welcome. Also, the directory standard I showed you. So as you see up here, this is the definition file, but this is the definition I came up with, which I call Unix-ish, because it's very much oriented on the Unix file system. But it's also possible for you to define your own, for anyone. That could be interesting, especially for people that have lots of projects that already follow us on that maybe makes more sense to them. They could just come here, make a pull request with their own directory that contains a README and this file. So this is an alternative which you see has different entries. And if you do this, then the tool will automatically pick it up and also recognize your structure. Or questions maybe?
Yeah, so I don't have more questions, but I think that it's great that you are doing this. It's important for the open hardware projects to understand where they can improve the documentation. I think the next step, I don't have anything to because I think that you have a lot of stuff already checks that you've written already. I think the next step is to get more people to use it. Yeah. But thank you very much. Thank you for doing this.
So the next question would be, so if people are interested how to follow up, just like go through your documentation and try to use it, or can they contact you somewhere? Where can they contact you?
Well, best case scenario, right? Yeah, I mean, the GitHub repository has already a lot of issues where there are discussion happening. I have been participating in some of those discussions. So, yeah, that would be interesting, right?
Yeah, you can even just write an issue on the tools GitHub repository and ask for help. How can I use this in my project and so on? I can help you.
Yeah. And are you going to be at any events where people can meet you also, like to sit down with you and go through stuff?
Well, I just follow the events of open source ecology.
Yeah.
I don't know.
The open source ecology events will probably host some of those tools, but also maybe from a media perspective, which also might be interesting for some people, because that was a deep dive into the actual technology behind it, into the structure behind it. But I think also people will need some help by implementing it, for example. First steps, that's what was originally my question, who has actually done some documentation already? Because I think you have to be experienced at least a little bit on how documentation works, how to document your own project in order to think further on how to improve your documentation. Because in the case of hardware, it takes a moment to get, it needs some practice, right? And maybe we actually can run a few practical workshops on that, but that we have to define those first for next year, yeah. I would actually love to do some hackathons similar to that, what we did in Hamburg, but focusing less on just the tool side of how to design open source hardware, but actually how to document it with such tools, right? To integrate both of concepts into that.
So Alessandro, you also work in open hardware. You worked on the spectrometer, for example. What's your feedback so far? Is that like useful for you? Could that be useful for you, or what's your feedback to them?
Yeah, that from someone that is has not an engineering background, so I'm biologist. I struggle in the documentation because I'm not familiar with the way engineers document their work. And so for me, yeah, I have the issue of needing support from the maker's perspective. So from someone who needs to design the documentation. And so I have to check which part do I have. For example, do I have software? Do I have hardware? Which type of hardware? And for each type of, so with each group of these parts to document, what do I have to document and how? What is the standard of the documentation? And being someone who has no clue even where to look, where to start from, I would like to have these kind of hackathons when you get together and you get a bit of support to draft at least the way you need to document. And then you go home, you do the whole documentation, the whole description, and then you go to hackathon number 2 and you clean it up. Yeah.
Yeah, good idea. One question that I have is not related. So the project that you select, the insulin pump or something, where did you get this project? So is there a directory of all open hardware?
Yes, there is. I don't know if this one is in this repository. No, this one probably is not, because, but I showed you the website. Where is it? Yeah, I will post the link.
Will you put the link on Telegram, please?
Yeah. I killed Telegram.
So in regards to the hackathon, do you have any plans? Is that an idea that maybe we could follow up the hackathon? Yeah,
it would be great.
Yeah,
I mean,
can open source ecology organize that, for example, with Tim? That would be great. Yeah, we definitely would be happy to share it on our channels. Take it home as an idea, maybe. Yeah.
Okay.
Cool. Yes, I think that's an outcome for next steps. So we can check out this tool. There could be a hackathon. Fuk is going to build an insulin pump based on the documentation. And yeah, I can see quite a few next steps. Any final questions from you guys? Like, yeah, are you like, do you get a basic idea now? Like, you have a lot of LED projects.
Yeah, but I have not documented them in this structure. I did not know that. Are there any other projects that are similar to your project?
No, not. There's no automatic check. There are some standard, for example, the open meter done by Robert Mies and his people, but this is only a textual description. What should you have and so on. And actually, my tool already checks most of the things automatically, the ones that can be checked automatically. And the idea is to also generate a batch. But no other tools.
It makes much sense to automate this.
Okay, cool. So yeah, so I think you reached a good group here of people, and would be happy to keep in touch. And you're also on the Meshcon channel, where you can like definitely, if you have any news update. And yeah, I saw you filed some issues during this conversation. So yeah, a lot of next steps, but you already did a lot of the work. Yeah, so then we'll see you. Oh, we move from here, right?
Yeah.
Yeah. So thanks a lot. Cool. Yeah.
I guess they are programming.
So I think we finished this stream now. So thanks for everyone online. Big round of waves here also from there, right? So we had a nice group of people here. You guys got some impressions. And yeah, catch you next time at the Meshcon. Thank you. Bye.
So
Stop this also.
Yes. Could you give me the glue? Thanks.